So what I want to take a look at today is what an inequality is, how to represent an inequality on a number line, and then also have a look at how we can go about solving inequalities to find an unknown value. Now, essentially, an inequality is generally a range of numbers, all right? Instead of having one solution to a situation, we may have a range of solutions. And we can visualize this using a number line. So, for example, let's just focus on A here, where we've got our number can be anything greater than 1, all right? That open sides towards our number. X is just a whatever number it is. What we can sit here and do is we can kind of draw a number line out here, all right? And that number line is going to be our X values because we've got X as our unknown here, all right? What we know on this number line is at some point there will be the value of 1, okay? We would have 0 over here somewhere, 2 over here somewhere, so on and so forth. And it would go negatives onto the left and positives on the right, okay? What we know about this is our number can be anything greater than 1. So essentially, our number can be anything over this side of the number line. All right, anything greater than that will be our solution. However, what we also know is it can't be less than 1 and it can't be 1 because 1 is not greater than 1, it's equal to 1. So what we do here is we actually represent this with an open dot, all right, at that number line. Because what we've just shown here is it can be anything greater than 1, but the open dot shows that it's not at 1, okay? Similar can be seen when we look at the less than. So in this case, this symbol just in here is a less than symbol. Let me just get the eraser out quickly. Is a less than symbol, so it means that it's more negative than -3, okay? So we can include this on number line as well. So let's just draw a number line out. And it's our X values again. And what we know about this, so we might have -3 here, all right, and that would be obviously -2 over here, and then over here would be -4. You could draw a bigger number line, but I'm just kind of illustrating the point here. We know that this solution, our unknown value that we've got here, is anything less than or to the left of that -3 value. However, it's not equal to -3, so we would use an open dot once again to represent this. Now, what changes here between this symbol that we've been looking at here and here compared to this symbol here is we've got this extra dash here, or it's kind of like an equal sign, well it is. And what this tells us is it can be greater than +1 here, or equal to +1. So similar to our first little diagram that we drew to try and illustrate this, all right, we know that our solution or our range of numbers that we're describing here, all right, is anything positive or on the positive side of +1, okay, more positive than +1. What we also know though is it can include that value of 1. So rather than using an open dot, we actually include a closed dot here, and this is how we visually represent that our range of numbers that we're looking at here on a number line is anything more positive than 1 but also equal to 1. The same thing obviously applies when it's less than as well. Okay, so let's quickly draw a number line. We're dealing with 13. I'll just quickly include a couple of numbers around it. All right, in this case is less than 13, so it's more negative than 13, but it can include 13, so we would do a closed dot. Okay, and we generally include the X here because that's the variable that we're looking at. So that's kind of what a inequality represents. It represents a range of numbers, all right, on a number line, and we can show it like we've just done here. Now, when we start looking at inequalities themselves, we can start to think about what happens if we were to do some of the things that we were doing with equations, where we're adding something to both sides, subtracting something to both sides. We used to have this rule with equations. When I say it used to, it is a rule with equations, where we can do anything to one side of the equation as long as we do it to the other side of the equation will still balance. Now, similar is true with inequalities, and for the most part we can just keep the inequalities the same direction, but we have to consider some special situations. All right, so let's consider this inequality here. What this is saying is 5, the number 5, is greater than 2. It's more positive than 2. And if we think of our number line, all right, this is really obvious, but let's just quickly draw it out. All right, 2's down here somewhere. We would have 3, we would have 4, then we would have 5. All right, 5 is more positive than positive 2. Okay, so that means that 5 is greater than 2. What if we were to write this statement the other way around? Because when we have equations, let me just think about this, like 2 equals 2. I can rewrite this the other way around and I will get the exact same thing, okay? With inequalities, that's not quite true. Because if I was to rewrite this the other way around and have this 2 and 5, well, 2 isn't greater than 5. That doesn't make sense. So what we have to do is if we ever rewrite this the other way around, we actually have to change the sign of our inequality to make the statement true. Okay, and we can change it around anytime we want, but we just have to remember if we swap the left-hand side with the right-hand side, we reverse the inequality sign. Okay? Well, what happens when we add and subtract to both sides of the inequality? Well, let's consider that. Oops. Let's consider that. What if I added 3 here and I added 3 here? Well, I would get, hang on, let me get the blue. I would get 5 on this side, I would get 8 on this side. Well, 8 is greater than 5, or 5 is less than 8, so the inequality sign stays the same direction, okay? So, and this is going to be true for any kind of addition and subtraction. So we can actually add and subtract whatever numbers to one side, as long as we do the exact same to the other side, it will not affect the inequality sign. It's different from when we reversed it. The similar is actually true, so let's just quickly over here take our 5 is greater than 2. Similar is true when we're multiplying or dividing by a positive number. So let's just say that I wanted to multiply this side by 2 and this side by 2. Well, when I do that, I would get 10 and I would get 4. Okay, and 10 is still greater than 4, so that worked. And if I did the opposite, let's say I divided by 2, divide by 2, well, obviously I'd get back to where I was, 5 and 2, and 5 is greater than 2. We can see that, all right? However, and this is where a new rule comes up, if we weren't to multiply and divide by a positive number, but by a negative number, so let's think about this. If I multiply by negative 2, multiplied by negative 2, we would get negative 10 and negative 4. And we would have to consider, well, where is that on our number line? Well, negative 10 will be over here somewhere. Let's just say this is negative 8, negative 6, negative 4. We can now see on our number line that negative 10 is more negative than negative 4. So it's actually less than negative 4. So we have to flip the sign of our inequality. All right, and that kind of sums up the differences between equations and inequalities. Essentially, equations, we learned that we can multiply, divide by any number, add and subtract any number to one side, and as long as we did the exact same to the other side, then we'll keep the equation balanced. We can do this same thing. We can treat inequalities like equations, except when we flip them, we change the sides of them, we have to reverse the inequality. And when we multiply and divide both sides by a negative number, we have to reverse it. Other than that, we keep it all the same. So, well, how does this apply when we're solving inequalities? Well, those types of problems look like this, okay? Very similar to our equations that we've been solving up until this point, where our equation might have looked like x take 4 equals 5. Okay, and we need to look for a number that when we subtract 4 from it, it equals 5. We're going to do the same type of thing here, except, we are now going to use the inequality. So how would we go about solving this? Well, the first step would be to do the opposite of subtracting 4, so that'd be to add 4 to both sides of the equation. Now we can add to both sides without changing the sign of the equality. So that means that our x is going to be greater than 9. We keep the inequality the same direction. And if I wanted to show this visually, I could. Okay, here's my 9, and our solution is going to be that side to the 9. It's more positive than 9. Doesn't include 9, so it'd be an open dot. All right. Now, in the next question, we've got 3 multiplied by a number, so the number's b. So 3 multiplied by b is equal to, is equal to or less than 9. All right, so to solve this, well, we'll do the opposite of multiplication, which would be to divide. So we divide this side by 3, divide this side by 3. Now we are dividing, but we are dividing by a positive number. So when we divide by a positive number, we keep the same direction of our inequality. So what this means on the left-hand side, we'll be left with our unknown value of b, and the inequality sign will stay the same direction, and 9 divided by 3 is 3. So what we've learnt here is, I should have actually put the x here. Our unknown number of b, okay, is going to be this side of 3, is going to be less than that, but it could also include that position, so it would be a closed dot. All right, one last one here. I've got 4 subtract 2x is greater than 0. This is going to require 2 steps to solve this. The first step, I need to get rid of the 4, so I need to subtract 4 from both sides. When I do subtraction, I keep the inequality sign the same. Doesn't matter what I'm subtracting. So that'll mean that negative 2x is still greater than negative 4. But I now need to divide by negative 2 to get the negative 2 to the other side, essentially. So I'm going to divide both sides by negative 2. All right, now this is where we need to remember that when we divide or multiply by a negative number, we have to change the sign of the inequality. So what this now means is our x value has to be less than positive 2. All right, and then if I was to draw it out, our x value is going to be to the left-hand side of positive 2 with an open dot. So we can essentially, just summarize, we can essentially treat inequalities when we're solving them as if it was an equation, okay? Except there's a couple little rules we have to remember, in that if we ever change the sides of the left-hand side and the right-hand side, we have to change the direction of the inequality. And if we ever multiply or divide by a negative number, we also have to change the direction of the inequality. Otherwise, the inequality stays the same direction.